Hello and welcome. My name is Tarek Abla, and welcome to this video tutorial on a small-scale distributed system. This system is composed of three separate machines, or nodes per se, and the primary goal of the system is to demonstrate basic inter-process communication across a network. And this will be demonstrated using a client-server model, where the system performs a simple but yet a complete task. One client sends a series of numbers and a server stores them, and the second client retrieves them to perform a calculation. And this calculation will be a mere average calculation of numbers. This setup meets the requirements of such small-scale distributed system. It uses different operating systems naturally and different programming languages to apply this client-server architecture. So, what are the system components and roles? The system is built on a distributed network of three distinct machines, each with a specific role. So the first machine will be symbolized with M1, and this will be this machine that you're seeing right now. This is my actual laptop, and I've installed two virtual machines using VMware Workstation Pro to simulate the other two operating systems. So the M1 here, it runs a Windows operating system and it acts as the first client. And this client is hosting an app which is called A1. A1 is to be seen here in the Visual Studio Code IDE here. I've written the whole program. Yes, and this will resemble this client that we're talking about. The language that was used, the programming language, is C++. And the purpose of app1, or A1 in this case, is to allow the user to input a series of numbers, and then it takes this data and sends it over to over the network to the server on machine number 2, which is encoded or symbolized as M2. Yeah, so this brings me to my next point. I'm going to open Workstation Pro. And on this machine, I've installed the Ubuntu operating system, Linux. And yeah, so the server is called server.python. So as you can see, I've used the Python programming language, and it acts as a server. It runs the central server application, and it's written in Python. And its main function is to listen for incoming connections. So when a client, which is either A1 or A2, connects, it processes the request and stores the new data received from A1 and serves the stored data to A2 when requested, which resembles, hopefully, a distributed system. So in machine 3, I've installed the Kali Linux operating system. Yes, so on machine 3, it serves as the second client and hosts an app which is named a2.python, clearly written in Python programming language. It connects to the server on M2 and retrieves the stored numbers, and then computes and displays the average to be calculated. So this configuration uses three different operating systems. In summary, Windows, Ubuntu, and Kali Linux, and two programming languages, C++ and Python. So let's talk about a little bit about the network configuration here. So the communication between the three machines is based on the client-server model, and I'm using the TCP protocol here, the TCP sockets. TCP stands for Transmission Control Protocol, as many of you know. So we choose that because it's reliable, meaning it is connection oriented, and it's critical for this application as it ensures that the numbers are delivered in the correct order and without any data loss. So in general, I'm using the socket mechanism to be able to let the applications communicate with each other over this network. Naturally, this is all done in a local area network, so a LAN. Uh, Therefore, the IPs that are provided in the code are of my server machine, which is this Ubuntu right here, and not the gateway. So, regarding the socket communication, the server creates a listening socket. So that's what it basically does. It listens, and it is bound to a specific IP address and a port number, which is going to be 8080 because it's the TCP protocol. It waits for the client to connect. This is the meaning of listening. It waits for the client to connect, listens for requests coming from clients. The clients M1 and M3 uh, create a connecting socket that initiates a connection to the server's specific IP address and port. Um, yeah, so the server in order for the server to be able to listen on all interfaces in the network, the IP address that it is listening on is 0000. And I think I can show you this right here. Uh, just go down a little bit to be able to see that. Mm, hmm. Yeah, and I'm not able to find it apparently. Yeah, there. The host is listening on the 0000 IP address, and the port number specified is the 8080, which is the TCP port. So, um, this is very crucial, meaning the IP address of the Ubuntu operating system here, or the machine. I mean the machine, because this is what's going to be implemented in the A1 and A2 applications, naturally, to be able to connect to the server. So they must be configured with the specific IP address of the M2 server and the port number 8080 to establish this connection. Um, so, uh, Data storage on the server is um, actually only plain file, a plain text file named numbers.txt. The server code uses the append mode to add new data to the end of the file, ensuring that no previously stored numbers are overwritten. Regarding the data access, the M1 client accesses the server through its TCP socket to send the new data. It transmits the user entered numbers as a single string. A2, on the other hand, meaning the M3 client, sends a specific request message called get numbers to the server, and the server, upon receiving this request, reads the entire content of the numbers.txt file and sends the full text string back to A2. A2 then processes this string to compute the average. So to run this system and for it to function correctly, the applications must be started in a specific sequence. And this will be demonstrated right now. So in order to do this, I have to start the server first, which I've already specified the path and everything. I just need to run the script. So since we're using Python, that will be Python 3 and then server.py. So as you can see here, the server has started listening on 0000 and the port number is 8080. And nothing shows after that because there are no requests coming. And we'll see what happens every time a client sends a request or the server receives data from client A1. So I've run the server now. It's ready. It's listening and ready to receive data from the client A1, and that will take me to my machine here, the Windows machine, where I'm gonna be running the C++ program or script. So, and there will be. So, I'm prompted here to enter a series of numbers separated by spaces. And I'll do such. 1, 2, 3, and 4. And hit enter. Um, as you can see, a message here is displayed, data sent successfully, with the size of it, of the string that has been sent. So we should actually see some changes happening on the server. And here it is. The connection was established with this IP address, and that means the connection was established actually. And this is the IP address of the client of the A1. The data was received, and here it is. So now we know, yeah, it was sent reliably through the TCP protocol, and um, A1 client with this IP is sending data, and it was appended to the file, which is numbers.txt as previously mentioned. So now I know that the server has stored this in a .txt file. The remaining step is for the client number 2 to send a request to the server to ask or request the stored data in the server. So I'm gonna go to Kali Linux. This is my M3, and I'm gonna run the script a2.python, which is responsible for retrieving the data. Python 3 a2.py. So as you can see, these prompts tells us that the connection was established, it was successful, and the request was sent using the get numbers that we talked about, a message. It waits for the data to be sent from the server, and you can see that it was actually sent. And then lastly, the average is calculated as to be, and is to be 2.5. And at the end, the socket is closed and the connection is terminated. And we can actually repeat this process, but in this order. So I believe, yeah, so now I've demonstrated that the three machines actually do what they are told to do. So thank you for watching, and see you in the next video.